whenever you are talking about heat exchanger, especially in boiler application, so the some term will be coming: fouling, scaling. Okay, so those terms will become: fouling means a dirt film on the heat exchanger surface. So I have heat exchanger, let's say this is water is going through this and hot gas is there, combustion gas, let's say hot gas outside, okay, inside water flowing. Uh, so if water is having certain contaminant, say contaminant may be a salt, whatever water you are getting from your tap or drinking water bottle, there will be certain amount of minerals. If that mineral is there and continuously water is flowing through this one and you are boiling also, what will happen? Steam will not take the salts, okay, or contaminants. Still steam will take only the water molecule, okay. uh, then what will happen? These salts will get deposited on the pipe surface, salt or dust or debris, whatever things are there. If those are getting deposited, your heat transfer rate will be reduced, because pipe material, let's say this is copper, pipe material is having higher heat transfer rate, okay. Now you have fouling or contaminant or scaling, okay. So those material you will have lower heat transfer rate. When higher heat transfer rate pipe is there, now you have another layer lower heat transfer rate. So you can remember the formula for resistance concept. So higher heat transfer rate, lower heat transfer rate, then that means your total heat transfer rate, average heat transfer rate got reduced, okay. So if water is having contamination or the fluid is having contamination, then you have to remove that contamination or salt content, then you can put for your water application, especially in boiler. Later I will discuss details about boiler flow, okay. uh, in some cases, because this is steel pipe or copper pipe, lots of salt will be created because of corrosion, okay. Those also will be deposited on the piping surface, okay. So scaling, most common form of fouling associated with inverse solubility of salts, okay. Salt like calcium carbonate, calcium sulfate, lithium, magnesium, lots of salts will be getting deposited on the surface. Corrosion caused by chemical reaction, process, steam, and many cases if oxygen is there, that also will create like some corrosion at high temperature. Freezing fouling, paraffin, so especially in oil and gas application, paraffin frequently solidifies and creates gas hydrate, that will also be deposited inside piping system, okay. Biological fouling, microbes inside heat exchanger, particularly fouling microscopic size particles in solution, so that also will be creating fouling. So fouling, what will be the effect? It will be narrowing the piping diameter, increasing pumping power, means narrowing down pipe. So you have already fixed pumping power and system working, but you narrowed down pipe. Narrowed down pipe means lots of pressure drop will be there, okay. Lots of pressure drop means pump must be working high, okay. So pumping power will be increasing, so you have to give more electricity, more power here, okay. Increasing thermal resistance, so thermal resistance increase because this fouling is having lower heat conductivity, take more heat to boil water or more cooling to reduce the temperature of water, or increase energy cost due to reduced efficiency. So fouling has a negative effect. So whenever you are putting water or anything, so you have to consider all the parameters, then you can handle things smoothly, because whenever you design on boiler or any system or you are using, so if you are not considering all this part, that can be dangerous also. Let's say pipe is blocked and you are creating lots of pressure, pump is trying to work hard to cross this barrier, the pipe can burst or leakage can be there, so that can be dangerous, okay. So if there is any restriction of fouling is happening, so you have to take care. Thermal resistance, overall heat transfer coefficient can also be calculated by view of thermal resistance R. So we already discussed about thermal resistance like electrical analogy. So already we discussed about electrical analogy regarding thermal resistance. The heat transfer between fluid and the wall is one resistance, wall is self one resistance, transfer between the wall and the second fluid is another thermal resistance. So therefore different thermal resistance will be there, fouling, thin boundary layer fluid film, then metal boundary layer, maybe another insulated layer. So, different layers are there, we have seen the formulation. Okay. Surface coating or layer or burnt product adds extra thermal resistance. So, if there is, you design your system, but if we are getting extra deposition or coating or anything, then again resistance will be increasing. Some typical heat transfer resistance, static layer of air, it will have R equals 0.1 meter square K W, 40 millimeter thickness, okay, 40 millimeter. Inside heat resistance, horizontal current, okay, inside pipe heat resistance, horizontal current, horizontal flow is there, then R will be 0.13, okay, for air. Outside resistance, inside, outside will be 0.04, okay, same unit will be same. Inside heat transfer resistance, heat current from down to upward, okay, leave it. Fin or extended surface, here I have taken some picture. You use the fin for industrial purpose. For example, in computer you have lots of fins actually. This is metal and these are the protrusion fins, okay. So, fins will be having almost same temperature as base metal, okay, this is base metal and extended same metal actually, continuous metal, then heat transfer rate will be increased. But here maybe in your hostel you have seen this type of compressor for your cycle pumping, bicycle pumping, okay. So, here heat exchanger is there, okay. Why? These, there will be piston cylinder arrangement. So, there air compression is happening. When air compression happening, so inside air temperature will be very high. So, that high temperature, if you reduce the temperature actually the system performance will be increasing. So, that is why these fins will be there, okay, fins or extended surface. Those extended surface will be reducing temperature of the cylinder, so that whole system performance will be increasing, electrical power consumption will be lower. In computer also, if you do not reduce temperature, your maybe circuitry can burn, okay. And in motorcycle, if you see there is engine actually, piston cylinder arrangement will be there and these are the fins, okay. So, those fins will be reducing temperature and here normally when you are not driving, so it will be having natural convection because there is no air blow and your engine also taking less amount of power, but when you are driving engine will be taking more amount of power, it will be generating more heat. So, that time air also will be blowing over it. So, it will be creating forced convection actually, okay. So, they have created the engine outside, so that whenever you are driving, air will be passing over the fins and it will be creating a forced convection and heat transfer rate will be higher and engine will be safe, okay. So, extended surface of fins, to increase convective heat transfer coefficient, fins should have higher thermal conductivity. So, whatever fins are there, normally it will be aluminum, iron will be lower application because aluminum will have very high heat conduction rate than iron, 250 around something we have seen already. Within fin, heat transfer by conduction be happening. Let us say I have one fin here, this is my metal, okay. So, this will be same metal normally, same metal will be there both, okay, and this will be higher K. If it is having very lower heat conductivity, there will be no use because this temperature is 100, this whole fin must be 100 degree, almost 100 or 99 up to this, okay. But original metal will be 100 and fin other end is 30 degree, that means this fin will not work. So, you need very high heat conductivity through this one, so that whenever heat will go outside from because of convection and radiation, the heat will be flowing directly from metal to the fin quickly as soon as possible, so that again the temperature, fixed temperature will maintain on the fin and heat will be dissipated in the surrounding. So, temperature difference will be maintained. So, good convective heat transfer will be maintained because del T is there, Q proportional to del T, okay. What are the different shapes of fins? Fins are surfaces that extended from an object to increase heat transfer rate. Fin material must be high conductive. So, fin's shape can be like this. Okay, I am drawing one. Okay, so fin shape. So this is my fin. Okay, this is W width and this is fin length. Okay, length cannot be very long because very long means base metal temperature and other end temperature. If temperature difference is very high, very long means heat will be dissipated. You say this is my base metal, this is my fin. So 100 degree centigrade, 100, 100, 100, 100. If it is very long, then heat will be dissipated all around, and when it is reaching this end, this may be 30 degree. So this portion may not be useful. So just make smaller and make it better. And if you make very long also, then air flow or other fluid flowing over it, that flow also will get resistance. Okay, so you have to make a optimal shape and sized fin so that airflow will not be blocked so much, and heat conduction will be proper, heat convection also will be proper. So you are getting benefit from conduction convection both, and not restricting the fluid flow. This is triangular fin. Okay, another can be rectangular fin. Rectangular fin can be like this. Okay, it will be like this. So this is a rectangular type fin. Okay, another can be like trapezoidal. It will be not sharp pointed, rather it will be like this. Okay, this is trapezoidal type of fin. Trapezoidal, and there can be a parabolic shape. Parabolic shape fin will be like this. Okay, this parabolic shape, and it can be cylindrical shape, pure cylindrical like this. Okay, this is cylindrical. Okay, so many type of fin possible, and those are being used in the industry. For example, very thin film, rectangular type fin will be there in a micro channel application. Micro channel where? In your computer application, very narrow, very thin sheet you are creating, and a very small space like 1, 2, 3, 4. So very small space will be there in between. Okay, so through that some air will be passing and heat transfer rate will be higher, and it will be very high conductivity. Normally aluminum will be there. Now you see the, for example, rectangular fin. Okay, this is a length L, and D is your thickness, and A is your this length. Okay, so ideal case will be like if T temperature A, so whole temperature will be TA. This is ideal case. Okay, and heat will be going out, conduction through this fin, it will be conduction. From conduction, from surrounding, it will go by convection. Then another will be radiation also possible. So you are trying to take benefit from all the three modes of heat transfer. In ideal case, temperature will be same, base metal and fin. Okay.